Shut up and sit down.
So first off, we're going to take a look at our saw. In this clip here, you can see the green on button along with a few of the other things we're going to cover. So we have the emergency stop button, which is that giant red button. You'll just press that in case of any emergency. And then here's our hydraulic valve. So as I turn that, the saw is going to go down at a faster rate the more I open that valve. And then as I close it, that will also stop it. You can all see right now, this is the automatic shut off. So as it's cutting, when it gets to the end of the cut, it will automatically turn off, so there's no need for you to stop that. So here I'm just using the 6-foot level to level out the tube with the roller in the back. It's important to make sure it's level because if your piece is in there at an angle, then it's going to also cut that angle. So having that tube straight and flat is going to be critical to having square cuts. Here you can see the saw blade is a little bit off from 0, so we're going to reset that using the combo square. So the technique that I'm using here is I'm setting the combo square up against the rest, and then I'm bringing the saw out of square, and then I'm just slowly bringing it in until I don't see a gap on the back of the combo square. And that's how I know that the saw blade is running as close to 90 as I can get it using these tools. It's also important to note that you shouldn't over tighten the screw once you find the correct angle and lock it in. Now what I'm going to do is I'm going to cut the end off so that I know that I have a nice square piece to work with, and that's going to allow me to get more accurate measurements. Now I'm going to take my tape measure, and it has a little magnet on the end of it, and I'm going to put it on the saw blade, and that way I know the exact edge that I'm measuring to, and then I'm going to pull it to the edge of the tube, and when I find my measurement, that's when I lock it in. It's also important to note to clean off your workspace. I'm using air here, but you can also use a paintbrush or something along those lines to clear the shavings. So here's the feet that we're going to be welding onto the bottom of our 2x2 tubing. Now this is a 4x4 plate, so my combo square and put it to 1 inch, and then when I put that on the edge, I'll put a mark all around the plate. That'll tell me where my tube is going to sit, and then I'm going to use a grinder to remove the mill scale so I can weld it. Now, we're also going to take a look at what grinding process can be the fastest and the most cost efficient. So here we're going to compare the difference between a flap disc and a hard rock grinding disc. So this is a rock disc, and it's great because not only is it economical, but it also removes material rather quickly. The one downside of this though is that it leaves a harsher finish. So this is a sanding pad on our grinder, and what's great about this is that it can remove material rather quickly and leave a decent finish, but the main downside is that it wears out rather quickly too, and you need to swap them out. So it can cost a lot more, as these cost about $1 a pad. So here you can see the rock disc is removing it rather quickly, but it's not leaving that great of a finish. And here's our sanding pad. You can see it is removing it rather quickly, and it's leaving a wide area, which is convenient for our purposes. So you can see right now that we're on our second one, and the removal rate has already decreased. So it's almost time to swap out the pad for a new one. So this is where the extra cost can come in. So now what we're going to be looking at is cutting the cross-sectional parts out of that 1x1 tubing. So this next section is just going to go over how to calculate that and using the Pythagorean theorem. Okay, so here we have a blueprint of what we are trying to make. You can see I have the 2-inch tubing on the outsides, and then I have that diagonal piece that we're trying to measure. Now, the overall measurement from the outside of the tubes is 24 inches. And since that's 2-inch tube on each side, that means that the inner dimension is going to be 20 inches. So we're going to look here and establish the angles. We know that we're going to cut this at 45 degrees. And then we know that's also supposed to be 90 degrees, which means the other side has to be 45 degrees. Now, we'll notice that this sets us up with an isosceles triangle. So we're going to try to find that bottom length, and we're going to use the Pythagorean theorem to solve it. So first off, we're going to label our A, B, and C lengths. We know that the bottom is 20 because of our last picture. We proved that. So that also means that B has to be 20 as well. So now that we've labeled C, we're going to go and take a look at the equation to solve this. So the Pythagorean theorem is a squared plus b squared equals c squared. So now we're going to input those numbers into our equation. And so that's going to be 20 squared plus 20 squared equals c squared. So it's going to be 400 plus 400 equals 800. So that means 800 equals c squared. So the square root of 800 is going to equal c. So that is rounded up about 28.3. So the actual decimal was 28.28. And the closest equivalent to that is going to be 9/32, which is 0.281. So now I'm setting up the saw to cut at 45 degrees. I'm using the same procedure as before where I would overshoot, and then I'm bringing in the combo square with a 45-degree angle on there. And once I find where it needs to go, I lock it in. So here I've already made my first cut, and now I'm putting my tape measure at the end of the tube, and I'm going to mark out to 28 and 9/32 of an inch. Then I'm going to take my combo square and mark out the 45-degree angle to cut. So now we're just marking out the line, putting it at 45 degrees, and then we're going to use that line to line up with the saw. So now all I'm doing is I'm taking my level and I'm using my tape measure to make sure that both these are 2 feet across. So now that I have the bottom clamped in at 24, I'm adjusting the top and then checking the diagonals to make sure that it is square. So on this welder right here, I already have the gas hooked up. So all I have to do is take my quick release fitting, connect it in there, take my DINS connector, put it in there, give it a little turn so it's tight, and now I've got my TIG torch plugged in. The next thing that we're going to have to do is we're going to have to plug in our foot pedal. So I'll unwrap this here. And the foot pedal has these little pins that you have to line up, and there's just a little indentation there so you can find the top. And then once it plugs in, you'll just screw it in so that it has a secure connection and doesn't come screwed unplugged. Now, the next thing we have to do is then take our ground, plug it in there, we're ready to go. So here I took some 1x1 aluminum angle and I'm using my porta band to cut it. And then after I've cut it, I'm going to use a file to just clean up all the edges, and I'm actually going to round the corners just so I don't catch anything. You know, since this is a tool now, if you're going to be using it and you're going to be handling it a lot, it's good to knock all the edges down just so you or someone else doesn't hurt themselves using it. It's really important when you are making products in industry that someone later down the road can't hurt themselves when they're using it. So here's my setup for tacking. I took a piece of angle iron and clamped it to the tubing, and I have a little bit hanging out so I can rest my tubing on there, and that way I know that they are both flush on the bottom side. Now I'm quickly going to tack it, and once I get it tacked, I'm going to move on to the next one. So now you can see all I did was I repeated that process all the way down until I got this zigzag pattern. So now that I've finished tacking in the one side, I need to flip it over and put in the other set of diagonals. What I'm going to do is I'm going to take a 6-foot level and a combo square, and I'm going to use that to align them, and then once I have them aligned, I will scribe a line for the other side. You can see in the photo here that once I have that scribe line, I just take the bottom of the edge and align that, and then I know they are aligned correctly. So here's an arc shot of welding some of the tube together. I'm just taking my cup and slightly walking it along the joint and dipping the rod in when it was needed. So at the end of this clip, we're going to look at the start in slow motion. You might have noticed that it wasn't a super smooth start, and I think a lot of this was probably due to an improper grinding technique that I used. I just used the sanding pad to grind that taper on there, and I think that's leading to some start issues. You can see right here, we get a really wide arc, and then it concentrates in on the actual puddle. Here's another quick shot of me just using the dip technique. That was really out of focus on this one, unfortunately. So here's the setup that I'm using to put the feet on the bottom of the tubing. I took that aluminum angle and I clamped it along with some scrap 1x1 tube, and that made it so that there's a 1-inch offset on the bottom and the left side of the tube, so that when I rest against those edges, it perfectly centers that pad on the bottom of the tubing. Now I just simply tack it in place, take the clamps off, and then I can weld it. So we're going to go review what we did today. We looked at how to use the saw and also how to set it up. We looked at how to measure out our parts and use the combo square. We had some grinders in there. We also looked at using some basic math to figure out the length of the parts we need and how to set up a TIG welder and some arc shots and techniques when we TIG weld.